Today we're looking at 3.03 intersection of graphs. Got a couple goals: solve and be able to explain how to find f of x equals g of x by graphing, and solve the equation f of x equals g of x by making a table of values. So what does f of x equals g of x actually mean? Think back to our last lesson. It's where the two functions equal each other, right? So that would be where the solutions are, but not just solutions to the system or system of equations, system of functions, but it is a system. Do you remember what makes this a system? Hopefully you thought, because there's at least two functions going on. Okay, so we have a system of equations and they want us to find the solution to the system, aka where f of x equals g of x. And as we learned yesterday, we can solve this two ways. What are they? If you thought algebraically and graphically, you are spot on. Take a moment to pause this and test yourself on it. And now that you've had some time to practice, let's go through it. To solve algebraically, you need to take one function and set it equal to the other. So, actually, let's just move this over. Okay, we want to solve for x, so let's get all of our x terms together on the left, and then that means we'll need to move our constants to the right. Okay, so we get 6x is 12, divide both sides by 6, so x is 2, but what's y? Well, remember, this point is a solution to the system, so it doesn't matter which function you plug it into. I'm just going to go with the first one. The numbers are slightly smaller. So 4 times 2 minus 3 is 8 minus 3, and that's 5. So when x is 2, y is 5. That is our one and only solution to this system. But it's not enough to know how to solve algebraically. We want to be able to solve graphically as well. So let's do that. These are both linear. The easiest type of line you could graph. F of x has a y-intercept at -3 and a slope of 4. So rise 4, run 1. 2 points is all we need for a straight line. So there it is. We have one line. Let's graph the other. Y-intercept of 9, slope of -2. So rise -2, negative rise, so down 2, right 1. Same thing again if you want another point, and that just so happens to be our solution. So you can clearly see on our graph that our solution is the same. 2, 5, our one and only solution to the system, because they're both straight lines. They can't cross more than once, like maybe a straight line and a parabola like we did last time. And now it's time to overview what your quiz will be like for 3.03. We're going to review similar problems. Number 1, you'll be given a table, and you need to select all the solutions to f of x equals g of x. Very simple when you know what you're doing there. Numbers 2, 3, and 4, that's the heart of your quiz. These are all very similar. You'll be given two graphs, and you need to pick which functions match the graph. Okay? And then find the solutions. And finally, given a word problem with two intersecting quadratic functions, find where they intersect. That will be how we close our lesson today. So here we're given a table. They're asking us to find where f of x equals g of x. And they're only going to want the x values of the solutions. Can you figure it out? So what's going on here? These are the x values of the points, right? And we know the name of the function can be substituted with y. So for the function f of x, these are all of the y values, and for the function g of x, these are all of the y values. If you don't have a solid understanding of how tables work by now, I'll give a quick overview. This is a point for the function f of x. So when x is 0, y is -2. And this 0, 10 is a point for the function g of x. So you can see f of x and g of x at this x value don't share the same point. So that is not where they're equal to each other. But if you go through the table, the simplest thing you could do is look for where does f of x and g of x match. Here they are the same thing. So at the x value of 2, f of x equals g of x. That's one of our answers. If you were to write it out, you would say, okay, for the function f of x, you have a point 2, 0. And for the function g of x, you also have the point 2, 0. Okay, just like we saw back here, right? We graphed two straight lines. Both lines share this point, 2, 5. Okay? Now going back here, we also see y values match at the x value of 6. Again, they don't ask for the entire point, just the x value. There it is. We are done. You don't even need to show this. So no real work to be done. Maybe take some notes and just know what you're looking for. Now you should have a better grasp on this one if you struggled with that last one. So give it a try. All right, you should have seen -2 and +2 both share the same f of x and g of x. So those are our answers. All right, we're getting to the bulk of this lesson, which is, again, like numbers 2, 3, and 4, you'll be given two graphs, or maybe even more than that, and you need to match the functions with the graph. These are the functions we want, okay? Now, graphing a straight line, you should be pretty good at that by now, but graphing a reciprocal power function, like f of x here with these red lines, might not be the easiest thing for you. You could graph it and solve graphically. You could solve algebraically, but I'm going to tell you right now, if you try to solve algebraically, it's going to take a bit of time. This is the long way, okay? Here, you would need to do what? Multiply everything by x to get x out of the denominator. Then you would need to get all your terms on the same side. So we can apply the zero product property. You would simplify by dividing by 2. And then you get to this point and we got to use the x method. You can tell it's going on and on and on. Well, instead of doing all of that, what if I told you you could solve this problem in about 5 seconds? Maybe 10. I'm going to give you a moment right now to think about it. How could you maybe do that? It's not solving graphically or algebraically, but look at the graphs. That's my clue. Okay. Pick any point that's on the line with whole numbers. So do I want to pick this point? No. We don't want to guess at decimals, right? I could pick maybe this point. Okay, and I'm going to choose the easier function, which is, well, actually, I just picked a function with a whole number I could clearly see. The red line is our f of x, so f of 2. Okay, so if this function matches this graph, if I plug in the x value of 2, I should get the y value of what? 2, right? This point is 2, 2. Let's see what happens. 2 over 2 is 1. That is not going to work out. So we now know the answer is B. If you instead wanted to approach this with the mentality of which graph is the right one, instead of just which is right or which is wrong, you could pick graph B and you could get even more specific and pick a solution with whole numbers. How nice is that? And then you could pick your easier function, g of x. You can plug in 1. And this point on this graph is 1, 2. If we get 2, which we should, because we proved A is not correct, we should get a point on our graph, and we do. So the answer is B. And after that point, we just need to point out our other solution, -1, -2. Matching and then finding solutions to the system. Let's do another one. Ooh, interesting. An absolute value function and a quadratic. Give it a try. All right. Once again, we fortunately see solutions that are whole numbers. So hopefully you're looking here and here on graph A and here on graph B. But which one matches? There's a few ways you could do this. You could graph them. I think that's probably the long way. You could solve them algebraically. I think that's maybe even longer. But we see lots of points with whole numbers, don't we? So we can just plug in values. Again, I would pick solutions. And solutions maybe with small values. Like right here, this point is, what is it? 1, 0. That is a very easy point to plug in. So if I plug in the x value of 1, it's on both lines, right? This point here. If I plug in 1 to either function and I get that point, then I'm all good. Okay, 1 minus 1 is 0. 0 is 0 away from 0. So the point 1, 0 does exist on this line. It's function A. That is a solution. And we see another solution right here at 4, 3. Okay. Finally, it's time for our word problem. Eli and Carl each throw a basketball straight up in the air at the same time. Eli's standing on a deck. Okay, visualize it. Eli's standing up on a deck at a higher level than Carl. And the height of his ball in meters is given by the function you see here. It's a negative parabola, which makes sense, right? He's throwing the ball up in the air and it's coming down. Okay, and he is up here on an elevated platform, right? Now, Carl, he's standing on the ground and he's throwing a ball in the air as well. It's modeled by the function g of x, where once again, x is the number of seconds after the ball is released from his hands. And there's a moment when the basketballs are at the same height. Do you see it in the quick little drawing? That's what they want to know. What's the height? What is the exact height when they are at the same height? Try it out. Answer will be in meters. Try it now. We will check it together. And I even gave you this helpful clue. You should know this already, but x is the number of seconds after the ball is released into the air. Think about a graph. X-axis is time. Y is the height in meters. Okay, we could graph these, but I would say solving algebraically is going to be much nicer. So here we go. Set one function equal to the other. If you want to test yourself, pause and work it out right now. Now, I know I want all my x terms together, so let's just say I want them on the left. notice those are going to go away. Minus 5x on both sides. Okay, and then I'm going to want my constant on the other side. So let's just subtract 3. Might as well do that all at once. So these terms go away. These terms go away. And these terms go away. And these go away. That is very nice. We're only left with negative 8x equals negative 3. We divide, we get divided by negative 8 on both sides. X is positive 3/8. Now they want the y value as well. What do they want to know? The height or the seconds? The height, right? And we said y is the height. So let's do it. To find y, plug in 3/8 into which function? Either function. Okay, why not choose the simpler looking function f of, in 3/8, let's divide it, let's get a decimal. That'll be nicer to work with. That's 0.375. I'm just going to round to 0.38 equals negative 2 times 0.38 squared plus 5 times 0.38. Okay, let's move that over. Moving everything a little bit just to make it easier to follow. Just a moment. All right. Now we have more room to work with. Beautiful. Okay, at this point, it's calculator work. So 0.38 squared times negative 2. That's about negative 0.29. Okay, plus 5 times 0.38. 1.9. Okay. And depending how they ask you to round, your answer might be a little different. Like if they ask you to round to the tenths place. Let's do that instead. It'll be even simpler, and there's a good chance that's how your quiz looks. 0.38 rounded will be 0.4. 0.4 squared is 0.16 times negative 2 is negative 0.32. 5 times 0.4 is just 2. Add those together, we get 1.68. We do want a positive value because we're dealing with height and might want to round that height to the tenths place as well. Time in seconds, height in meters. And that's it for 3.03. Study, practice, you got this. See you next time.